Hi, my name is Jonathan Tucker and I'm a postdoc at DTM. I'm going to be talking about mid-ocean ridge volcanoes and their natural emissions of carbon to the atmosphere. So mid-ocean ridge volcanoes comprise about 80% of the Earth's volcanoes. And there's also a substantial amount of carbon that's naturally put into the atmosphere from these volcanoes. But the actual amount of carbon coming out of the mid-ocean ridge volcanoes is not very well quantified. There are lots of different estimates of this flux, but a lot of them disagree. So what I'm going to be showing is that using noble gas data, we can actually constrain the mechanisms by which mid-ocean ridge volcanoes degas. And when we account for these mechanisms, we can actually come up with a new estimate of the global carbon dioxide flux out of mid-ocean ridge volcanoes. And what we find is that this flux is actually quite a bit higher than other estimates based on noble gases. But it's actually very similar to other estimates that are made independently of noble gases. So what we show is that consideration of the actual degassing mechanisms that are occurring at mid-ocean ridge volcanoes can actually bring these two different types of estimates into accord with each other. And by the way, the natural emissions from mid-ocean ridge volcanoes on geologic timescales are still a tiny fraction of the anthropogenic carbon dioxide emissions.